Alright, to wrap up this chapter, I really wanted to kind of drive home or emphasize the fact that just because you have a chemical in a compound does not mean that that chemical in the compound is going to act like the chemical on its own, or the element on its own. Okay? So for an example here, we're going to talk about oxygen and mercury combining to form mercury 2 oxide. So oxygen, when it's on its own, physical properties, it's a colorless, odorless gas. Excuse me. It is also soluble in water. Chemical properties, it is actually part of combustion reactions. Sorry. And it can also react with many metals. It's how you get oxidation on your metals. Okay. Mercury. Physical properties on its own, it is a silver-white liquid metal, so it's a very weird kind of looking substance. In the solid state, mercury is ductile and malleable, just like a regular metal, and then it can also be cut with a knife. Chemical properties, it does form alloys with most metals except for iron. It combines readily with sulfur at normal temperatures, reacts with nitric acid and hot sulfuric acid, oxidizes to form mercury 2 oxide upon heating. One thing that is not in this graphic, mercury as a liquid form is toxic to humans. I know I've talked about that before, but it causes insanity and, yeah, just really not good. So, most manufacturers are kind of cycling out their mercury production or mercury in different substances because it used to be in thermometers and a lot of other things, and yeah, it's not really used all that much anymore. So when you combine mercury and oxygen, you get mercury 2 oxide. So physical properties here, you have a bright red or orange red odorless crystalline solid. So with oxygen, you had a gas. With mercury, you had a liquid. You put them together, and all of a sudden, you've got a solid. It's pretty much insoluble in water. So where oxygen can be dissolved in water, mercury, not really. Mercury 2 oxide definitely cannot be. Okay. Chemical properties, it decomposes when exposed to light or at 500 degrees Celsius. And that's how you get mercury and oxygen gas back out. Okay, so you can see they're heating this here, and that's how you're getting the mercury and the oxygen coming out of this compound. Okay, so another common example of this type of thing that you'll see is sodium chloride. So sodium on its own, or sodium chloride is just table salt, but sodium on its own is an alkali metal, so it does react explosively or at least sparks in water. It's a very kind of soft metal, so you can also cut that one with a knife. And then when you talk about chlorine, chlorine is most often found as a gas, as chlorine 2 or Cl2. Okay, it is toxic. It's also a yellow gas. Yeah, it's pretty nasty. Part of chlorine gas, mustard gas. It's used. It was used in chemical warfare. Yeah, so really nasty stuff. But when you take one atom of sodium and combine it with one atom of sodium chloride, you get table salt. So you have completely different physical and chemical properties than you did with each individual atom, okay, each individual element. So this topic comes up a lot when they start talking about vaccines. So at least it used to be that a mercury-containing compound was used as a preservative in most vaccinations. Now that form of mercury, that compound, mercury-containing compound, has been tested over and over again and is shown to have no detrimental effects to humans, which is why it was allowed to be used as a preservative in these vaccinations. But then people started seeing the word mercury in the ingredients list and freaked out. So that is part of, that kind of got wrapped up in the whole vaccines and autism debate. And even though they don't use that preservative in most vaccinations anymore, you'll still hear that argument brought up over and over and over again. You also hear this a lot of times in like food. There was a whole thing about apparently Subway had a compound in their bread that was also found in yoga mats. Cool. So is water. Yeah, that's actually kind of a joke that goes around very frequently on social media in the somewhat sciencey communities of telling people that, this farm is using a very dangerous chemical called dihydrogen monoxide. People have been known to like die from it, from drinking it or from eating it. They can also, like, only 3 inches is enough to stop your breathing, yada, yada, yada. And it's meant as a joke, and then there's pretty much inevitably at least someone who takes it completely serious and then goes on a tirade against whoever was accused of using this chemical. And then people have to like start pointing out that, yo, dihydrogen monoxide means H2O. It's water. So, yeah. Basically, just because an element is dangerous on its own or dangerous in a certain compound does not mean that it will always be dangerous in anything else. And sometimes it's not even about the molecules or the atoms that are combined together. Sometimes it just comes down to the way that they're bonded together. Because there's one example, and I forget what the second compound is, but basically, it's the way the different compounds are bonded onto like the central molecule that determines if it's the taste of spearmint or if it's a poison. So, yeah, it's not even just about the elements, it's specifically about how they're bonded together. So, anyway, that was my little no science so that you don't get tricked by people who just want your money speech. Anyway, alright, that's it for chapter 1. So,